Just before we start this video, I have a small disclaimer. Half of this build will involve working with a UPS system. These parts need to be supervised by a certified electrician and a guy that knows UPS systems. UPS is a device that can be dangerous as it will produce 230 volts AC power. If you decide to build this unit and connect it to a UPS system, you do that on your own risk. I will not be responsible for any body or electric harm that came to you or your equipment as a result of mimicking my work. Hi, I'm Tamir and thank you for coming back to my channel. So in this video we're going to show you how to make these battery packs. I built them in order to give power to this UPS system. This UPS originally came with an option to install 10 batteries internally. The only problem was that they calculated the place only for a battery in a size of 5 amps each, meaning that's small batteries, and the result was of course that this UPS was holding very short amount of time when it was loaded. Since I wanted to use that system with a longer time of backup, I need to replace the batteries to bigger ones. And if you've seen my other movies, as you know, I decided to use this type of battery, which is the data-safe 12 volt 9 amps. If you didn't see the movie, you are more than welcome to see it now. Anyhow, so I decided that I need to have a battery pack externally. I looked online, couldn't find anything suitable. So I built myself 2 battery packs. Every battery pack is holding 5 batteries. It has an on-off switch, of course, for protection, because every unit gives us about 64 volts when it's connected in series. Every unit, of course, both of them has a handle in order to carry it, so it will be easy to move this unit from place to place. They are connected only with one cable between them. And as you can see here, I also added a socket and a switch in order to connect to our LED project. If you didn't see that as well, you are more than welcome to see it now. Currently this socket is connected only to one battery, so you can say, so what you did here, there's no advantage of the whole unit. You're right, but I can easily rewire the whole thing, as you can see, and then instead of connect it in series for the UPS, I can connect everything in parallel, and therefore this will give us a very long time if we use it for a LED light or for any other application that you need 12 volt, which are connected to 5 batteries instead of 1. So without further ado, let's go and see the video how to make these battery packs. So we're starting this build with 4 units of this measurement. It's 44 centimeters. We also need 8 of 32 centimeters, and the thickness of this material is just 1.7. Then we need 2 of 15 centimeters by 7.5, and again 1.7 centimeters thickness. And we're using 5 centimeters 4.5 screws, which are gonna hold a 3.5, and we're marking 0.8 from each side. And now we divided it for 3, so we have places for holes for our screws. Again, this is the measurements. Next, we'll drill them, of course. Then we take the 8.5 drill and we do a phase in order for the screws to go in and be flat with the surface. Again, we'll do it in all the sides of the place we drilled. And now we're drilling through the holes to connect all the pieces together and screwing up the screws. As you can see, eventually we're building a box that will hold all the batteries inside. By now we already have a frame, and now we're putting shelf inside. Marking for the screws that hold this shelf will be the same as we did in the 2 centimeters, 4 and 6. Again, drilling, holding it, and the spacer that we just put inside is one of the pieces that we also need for the continuous this build. So it's dual purpose also here to help us with the measurement, and also we'll use it afterwards in this build. And we're doing a phase with a bigger drill and then screwing the screws inside. Again from the other side, same process, making sure it's tied up to this spacer that we build, and then marking and drilling the holes. Now we'll mark the place for the breaker that we need to install here. So you saw the measurement, and just drill a hole inside, and then with a hacksaw just cut it out so it will fit this breaker. And you see in the background one of my LED is working here, and again just making sure it fits, and it fits nicely. A bit sanding, of course, with sandpaper. And then we're placing the hole for the on-off and the socket for the LED project, or any other application that you want to use this option. Again, I only did it eventually on one of the boxes instead of two. When I first designed this unit, I had an idea that I would put it in both, but eventually I thought that it won't be necessary, because again, I only need, in case I'll need these things, I needed only one, so I didn't do it on both, just on one of them. The whole thing, I'm starting with a regular drill, and from this hole I can then saw everything out. That's the way to start here. And again, making sure that it's fitting our plug nicely. A bit more sanding. And now I'm taking a plastic cover that came from one of the power supplies, again in the old project, things that left because we just opened the cover. And we're going to use this plastic as a base in order to put on it the sockets and the on-off switch for what we're building now, because I wanted them to be on a plastic surface, not a metal one, of course for safety as well. And I can't put them directly on the wood because the wood is too thick, and therefore the screwing for the screws or that hold these devices won't be long enough. So we need something thick and strong, which also is isolated. So plastic is a wonderful thing, and I figure since I have this thing left over, I can use them. But again, you can use any plastic that you have with the right thickness. And again, with the Dremel tool, just cutting out the extra edge which we don't need. Just so it will be nice and clean, to the right size of course. Again, a bit of sanding so it will be smooth. Now I just mark the place of the hole so I know where to drill the hole for the on-off switch and the sockets for the electric plug that will connect this unit to any device that needs 12 volts. So you see this is the mark. Just figuring out where to put the on-off switch. Again, there's no science here, just wherever you want to put it so it will fit. And this is the plug that we use to pin, of course. And everything sits in place. The only thing left is to, of course, connect this to the wood. 4 little screws that will be holding this plate to the wood. Now you see this is white screws, and you're thinking, why the hell white instead of black? And you're right, but since that was the only thing I had available, then I used white. But don't worry, eventually this whole build is going to be painted with black, so it has no meaning whatsoever. Now this is the part that we connect this unit to hold the breaker. Again, remember this, we used it before as a spacer, now it's fitting in place. Okay. Now we're making place for the handle that holds this unit. And then just measure the center, and now marking the holes where I need to drill them, of course. And drill them with a 6mm drill. Again, it's all dependent on the handle that you bring. If it's different size screws, then of course adapt whatever you need. Again, putting in the screws and closing them afterwards by hand, and of course afterwards tied it up with a plier or a key, whatever you have available, as you see here. Next will be to cut the cover for each side. As you see, I'm taking here a cover that I took out from a PC cover. Again, it's a panel from a PC case. Again, it has so many places that you need to flatten, so I just cut them out, and then with a, as you see here, just make it smooth. Eventually we need to cut it away as well because it's too big for our build, so I'm just marking where I need to cut it. And with this type of cutter, which will be the safest way to do it, again use gloves because it's metal and it's very sharp when you cut it, so for safety and for everything, it's helping not to harm yourself doing the way. So it's been cut to the right size, still not sand yet. Now it's that's the part is coming now, so it won't be sore. It won't cut you as a knife because that's how it is after you cut it. And now, of course, we're gonna drill and connect this panel with screws to the wood, as you see here. Again, a lot of flows, a lot of screws, so it will be very tight and it will hold. Again, doing the same thing I did before with a bigger drill to make a phase, so the screws will fit in just with the surface and won't be up. Here I didn't do it, so I'm doing it right now. Again, you cannot avoid steps that you need to take, otherwise it won't be the same. You need also to put screws here where the wood shelf inside this build exists in order for the back of this unit to be strong enough, because as you remember, we're putting batteries inside, and if the batteries will fall out, they have a big weight, so therefore this plate need to be very, very tight and very, very strong. So if the battery is being pushed inside, they won't take this plate out of place. So again, marking and drilling, same as we did every place, just need to put the screws in the right place, of course. And now I'm putting the legs for this unit. Again, it's something you buy at every hardware store. Just normal legs for any cabinet or whatever you need. Small drilling, not all the way of course, because remember we're working with 1.7 centimeters wood, so too much will be getting outside. And again, taking the 7 centimeter drill, putting holes inside the shelf where the wiring will go through. And since we have a lot of wiring, we need a few holes, as you see here. Again, you can make one big hole or small one. I'm taking the 3.5mm drill in order to drill a hole in this wood that will hold the breaker in place. I've been holding with, as you see, 2 screws, one in the side, one in the bottom. And with an angle here, it's connecting this place, and again a phase, so the screws go in and be flattened with the surface. Okay, now we finished all the drilling, and now it's time to solder the wires. So I'm starting with the on-off switch and the socket. Again, a very simple connection. The switch getting power, and then from the switch both plus and minus go to the socket. You see, it's very simple. And all the wiring starting to put the ending, as you see here. Depends on the plug that needed to be put, and with the right tool, of course, you do that. Since this video is already too long, I'm not going to show you everything I do here because it's, again, just work, there's nothing to see. But you're saying, okay, you want to know which wire go where, and for that I made a small diagram that shows exactly how to connect everything. So I'm just going to show you here a small part, and the rest we'll see in the diagram. Otherwise, this will be also a long time. Now, everything, as you see, being painted with a spray, black spray. Just took everything out and just took it out to the garden and sprayed it out a few times. I think this is 2 times after it got dry. And now I want to connect as you see, the measurements. So this will hold the door. Again, being built from another cover that we cut before, that was a side cover of a PC computer. And now I'm just drilling just a bit, so I'll have the marking, because I don't want to drill all the way here, otherwise I'll mark. And since I have this mark, now I can put wood underneath and of course drill all the way, because we want to install screws that hold this door. So this is the screws, small one. Again, it's screws which again fits this specific unit. I think it was 5mm, and the length was about 20. Now we're taking this rubber material, which usually come to isolate spaces between doors. Again, every hardware store has it, so it's not a problem. Again, I did also bought mine there, so I didn't purchase it online, therefore I won't put links for it. Again, you can just go and buy whatever you find, just act here as a spacer, and in order to put the door when it closes to a smooth closing, instead of a bang on the wood, because remember it's material on wood, and this way it's quiet as well, and of course it's more sealed. Just put it in, cut it with a knife, very simple task, and now when we close the door, it sits nicely. Now we need to install the lock. So again, marking the middle, according again to the size of this unit, and then very small screws to hold this in place. Remember to drill very slow, because I did a few tests and I accidentally break the whole wood part because of it. So again, slow and with the right thickness of the drill. The same method as you saw before, the marking, and then of course with wood underneath as putting it. Again, longer screws. This was 35 if I'm not mistaken. The length, of course, and the screw itself is a 4mm screw. This lock system I again pick up in the hardware stores, not something I picked online, so therefore you can find whatever you have available, just again standard for any box or ammunition box if you come from the army. Just holding it in place, and as you can see, voila, it's working. The door, I mean. We didn't continue yet. So next I took a Velcro or Scotch, depends how you want to call it, and then tape one side, male or female, doesn't matter, to the battery itself, and the other side, of course, will just took the stickiness covering and put the battery inside, so it's holding the batteries in place, and in case I need to take them out, I can easily as it's Velcro, you know, you can put in and take out. Next, we're going to see the diagram. So we're starting here with a plus going to the breaker. From the breaker, it's going all the way to the external plug, to the second unit. Second unit coming again to a breaker, which then go to the plus of battery number 1 on the top. The minus go to plus, the minus again go to plus, and the minus go to plus, minus to plus, and minus go out from the same plug it came in, back to the first plug, to the plus of this battery, minus to plus, and minus to plus again, minus to plus, and the last minus going to the plug of the input. After that, we have also here the UPS, which we didn't see yet. Again, we have plus and minus going to a breaker in the UPS and internally to the UPS power. So now I'm starting to work on the UPS itself to make a hole for the breaker. So again, this is standard, it's 2 cm by 4.5. Again, the breaker size, not something I invented. I just decided to want to put it in the side. And as you remember, the place I have inside, it's the place that was holding the batteries. That's why it's hollow. So again, starting with 2 holes, make them a bit bigger. The first one, as you see now, I'm drilling, going to be for Integron, which is a device that can hold the wiring and you can close it, so it's holding them tight, so they won't, even if you pull them out, they cannot go out. A very nice device. Again, this I picked in an electrician store. Second stage will be to cut the hole for their breaker, but as you know, if I won't cover it with a tape, then doing this process I can really harm the whole paint of the unit. So just covering all the places and also making by that the place I need to cut, and this way, even if I'm turning around with the saw, I'm not going to harm the color of this unit. Again, this is something you pick up from experience. You do it without, and then you see that the whole plate is full with scratches. And since this is painted in the oven, you cannot do it again. Even if you try to spray it, you won't get to the same size. And as you can see, after cutting, I just make sure it fits and taking out the tape, and everything looks as new, besides the hole, of course. And then with a Dremel tool, because this is not easy to do with this normal sandpaper, just sanding here so it won't cut anyone, me included. And the same hole is here. And now starting to solder the wiring. So again, we're using here big plugs, usually found in UPS, from my knowledge, usually APC brand use them. So I decided to go with it. It's a big plug that can hold a very large amount of current. The wire itself is 4mm wire. The type I'm using here is something that I just had in stock. It's a special wire. It's wire that are shielded with instead of rubber as you usually do. This is shielded with asbest. As you know, it's not the best material to touch, so usually use the gloves. And also, as you saw, I already put tapes on it. The wire itself is come in white, and it's a special wire that's designed to stand a lot of amount of heat. Usually you'll find this type of wire inside lamps or halogen lamps for more accurate, which getting very hot and you need the normal wire will melt. This one won't. Again, you don't need this wire for this build. You can take any standard wire with right thickness and use it. Just use that because I had it in stock. So I just put a tape on it with one with red and one with black, again to mark the plus and minus. And the plug, as you see here, it's very easy to just plug it in inside, and it's catching up inside after you solder the one end of it. And after you put it in, you cannot put it out. It's one way. And again, with a sleeve and shrink again to close it nicely. And now you're seeing me putting the cable for the input for the UPS, and this will go again to the battery pack that we just built. And now I'm putting the cable that go between the two units, which is basically the same, only it has two connector in each side. Again, soldering the plug. And as you see, basically I put a lot of paste inside and a lot of soldering, so it basically fill up the hole. It's like a hole inside this plug, so it's very good soldering because again it should hold a lot of current. You want it to be very nicely put. Then you shove it in and then it's stuck until you hit the click, and that's it. And heating up with a heating gun, and this wire is ready. So now opening the integron. This is size 11 if I'm not mistaken. Putting the wire inside and closing it with the sleeve inside even. That's what I want to make sure it's fine where it should go. And then heat up the sleeve so it will shrink and be the right size. So I'm just soldering out the end of my cable, the new one. And after that, as you saw in the diagram, the minus will be connected directly to the minus that came from the UPS cable, as I'm doing here. And the plus will go through the breaker to the plus wiring. And I put on it again a heat sleeve. The only thing I noticed afterwards is that after you shrink it, it looks very, very fragile. So not to take for another safety, I just put a tape on the sleeve so I have an extra layer of protection. And connect the plus to the breaker. Tied it good because you cannot take it outside afterwards, especially in this build. And below it is the wire that goes to our cable that we just installed. The top is going to the UPS. Now here I use, again, this is a part of, as you see, something that, again, with wood. I didn't put here the measurement because, again, it's specifically for this unit. Just build something, as you can see here, that holds this breaker. It sits on a rod that's designed to hold breakers in an electricity board. Since I'm also an electrician, then of course I have this type of stuff at home. And this is an ending for this type of rail. I'm just cutting here a bit because it's I have, as you saw, I have put a screw there, and because of the screws it cannot hold. So this will hold this breaker in place so it won't move. So I put two of these. You can see the other one in the other side. And then with zip ties, of course, tied up all the wiring so it cut the ends. And now it's time to close this panel. It's built from two pieces. One is the one with the control on it, of course, and the other one is just a cover. So again, two screws hold this in place. Only thing left to close this panel, again with two screws. Again, this door being closed, and I'm going to put a rubber protection on this plug. Again, something I picked up online, just to make sure when this plug is not in use, it won't get wet or dust go into it. So there is a cover that you can buy, as you see here, that holds it in place for protection. Hope you enjoyed this movie. If you do, give it a thumbs up, and don't forget to subscribe to my channel so you can get notified when I release my next one. If you didn't see the other two movies about the batteries or the LED light, you are more than welcome to see them. There will be links in the description below, or just go and visit my channel. Just as a small thing I didn't show you until now, that the whole system that we built works. So as a demonstration here, this is the socket that goes to the wall for this UPS, so you can see it's not connected to anything. And if I'll try to start it up, it doesn't work. So we'll bring this switch on, which basically connects the whole thing to the batteries. And then we can turn it on. And it works. So this was this UPS project, or any other purpose you can think of building a battery pack for other uses, if it's for a LED system or for something else. And I'll see you in the next movie.